Hello everyone, I'm Qiang. What I'm going to talk about is Flor, an open high-performance RDMA framework over heterogeneous RNICs. Let me start with the background. Today, RDMA is widely developed by many companies, and hundreds of thousands of nodes are developed with RDMA during the past 5 years in Alibaba. However, there are two problems. The first one is the coexistence of the heterogeneous RNICs. RNICs from different vendors are adopted. Meanwhile, RNICs from the same vendors of different generations are generally developed in data center. And then the second problem is the new requirement of RDMA in production. The first one is to relax RDMA operational cost, and the other one is to realize large-scale inter-port communications. These two problems bring about new challenges. The first challenge is that hetero-RNICs cooperate poorly. This is a severe bandwidth imbalance among heterogeneous RNICs from different vendors, as shown in the left figure. When a Mellx RNIC and a Broadcom RNIC send traffic to an inter-RNIC simultaneously, their throughput varies a lot, and as shown in the right finger, with a full match traffic test among these three different RNICs, a similar performance variation can be observed. The reason is that different congestion control algorithms are implemented in these RNICs. Then, even with the RNICs from the same vendor, but of different gens, there is a severe performance gap. In a hybrid development of Connect 4 and Connect 5 RNICs, the bandwidth gap between them is over 20%. And the second challenge is from the new requirement. It needs a new PSE-free and a larger RDMA effect. First, it needs to be PSE-free to relax operational cost. The PSE risk is not safely eliminated, and it happens repeatedly with the new cost. The left finger shows a new cost over the lack of memory bandwidth when a PSE risk happens, where a PSE risk happens when the memory bandwidth is approaching to the maximum memory bandwidth. Considering there are still lots of legacy PSE-based RNICs, the new RDMA must be compatible with this device. Second, with the development of disaggregated architecture, it needs inter-pod RDMA between computing and storage nodes. However, as shown in the figure, former pod-based RDMA framework doesn't work. With the inter-pod communication, the packet loss will increase, and the congestion control become more complex. Thus, it needs to be carefully deal with the inter-pod reliability and the congestion control. However, current RDMA is implemented by the hardware of RNICs and cannot deal with these two challenges. To solve these challenges, we present two findings. As shown in the figure, RDMA is composed of control paths and data paths based on this RDMA architecture. The first finding is that the data path function of heterogeneous RNICs follow the same RoCE v2 spec, while the control path functions are vendor and version specific. And the second finding is that the data paths of the RDMA need faster packet processing and high performance, while the control path is relatively slow RTT-related operations and need to guarantee efficiency. For example, reliability restriction is RTT-based, and its timeout usually multiple times of RTT. Based on these two findings, we give our key idea of this paper: maintain the data path of the RoCE spec in hardware for performance and compatibility, while unloading the control path to software over CPU, NPUs, and or DPUs for flexibility and openness. Besides, there are assisted functions for control paths, which include ECN, RTT, and so on. They are alternatively for hardware to further improve co-design between software and hardware. Then we present follow. It is an open unified RDMA framework as shown in the figure. Flor is composed of data path and control path. The data path is maintained in hardware. It includes basic raw key packet processing and memory transfer semantics, and two kinds of RDMA transport, RC and UC transport. Note that Flor leverages UC as the first citizen. The control path is unloaded to software. The key module of the control path is the dynamic chunking module, which is important for software and hardware co-design. And the other two main modules are the reliability module and the congestion control module. Both adopt software and hardware co-design to eliminate PSC dependency and realize internode communication. Besides, there are assist functions like RTT measurement and path switching. As mentioned above, dynamic chunking is the key of the control path. It adaptive chunk size according to the current network status as shown in the figure. The network status is defined by the RTT, timeout, and the congestion control. And if the network is of high quality, and then Flor dropped large chunk with hardware RDMA send or write operation to save CPU usage. Conversely, if the network of the low quality, it applies small chunks. The retransmission is enhanced by the software, where an efficient inter-trunk retransmission can be dropped. As to the RC transport, it adopts a chunking-based retransmission and enjoys a software and hardware co-design, where retransmission is not more than the retry time of RC. It adopts the default go-back-to-N retransmission by hardware. However, if the hardware retransmission fails for the retry times of RC, Flor will switch to the backup queue pairs and transmit wookies on them. For quick switch, Flor uses a small retry times, and for high efficiency, it adopts a small chunk size with dynamic chunking. In this way, it achieved an enhanced reliability of RC. Besides, for Flor adopts RDMA send instead of RDMA write to deal with the repetitive memory access problem. As to the UC transport, it leveraged as the first citizen. UC is a standard transport in RDMA spec with a simple logic. It's easy to implement it. And it is out-of-order transport itself. Thus, it quite fit for popular out-of-order transport like RPC in data center. With the flexibility of UC, Flor relies the selective retransmission with the UC RDMA by software, similar to Quick. Flor adopts two sets of sequence number into each RDMA wookie, and these two sequence numbers allow Flor to identify the origin wookie and the retransited ones by different global numbers. This is important for accurate RTT measurement. To avoid data copy, sequence numbers are encoded in immediate data with the RDMA writer with the IM operation. More details is shown in the paper. Flor adopts a default RTT-based congestion control. It's similar to Swift, as shown in the figure. Flor designed an accurate RTT measurement with hardware timestamp to improve the accuracy of ACK timestamp. Flor adopts a high priority UDQP to send and receive AC keys. More details is shown in the paper. Then we give the evaluation of Flor. RDMA is chosen as the baseline. It is the vanilla Rocky V2 base library and widely used in Alibaba. First is the micro-bench evaluation, as shown in the two left finger. Flor achieved a comparable throughput as the vanilla RDMA with a low CPU usage. And as shown in the right finger, Flor after performed the lossy and lossless setup across all the drop ratios. And then is the intra and inter-pod performance, as shown in the left finger. For the intra-pod traffic, Flor is comparable to RDMA, and as shown in the two right fingers, for inter-pod traffic, Flor is more stable and balanced than RDMA. And then is the larger scale in cast, as shown in the finger. Given the maximum in cast degree, 6,000 to 1, the throughput of Flor is nearly consistent of 50 gigabytes per second. And as to the number of OOS, which means the packet drops, is nearly zero when the in-cast degree is less than 4,000 to 1. And then is the performance of heterogeneous RNICs, as shown in the left finger. The bandwidth of heterogeneous RNICs is more balanced with the Flor than the orange direct connection. And as shown in the right finger, the throughput gap of Flor between Connect 4 and Connect 5 is 1.3%, compared that of RDMA, 24.3%. And then is the application performance. For Alibaba block storage service, the latency and the RPS performance of Flor is compatible to RDMA. And for Alibaba big data applications, the performance of Flor is 10% higher than RDMA. And the last is the evaluation of non-stop update online. From PSC-based RDMA to PSC-free Flor, it achieved a slight jitter, less than 2%, where all RDMA metrics are healthy. At last, we give a conclusion of the presentation. Flor is an open high-performance RDMA framework over heterogeneous RNICs. It maintains the data path of Rocky spec in hardware for performance and compatibility. And it unloaded the control path to storage over CPU, NPUs or RNICs or DPUs for flexibility and openness. The nature of the network is interconnection. And therefore, in the future, we want to build an open RDMA. It will follow the standard spec, and it can be developed in program RNICs, DPUs, CPU with CXL technology. And okay, that's all. Thank you.